Hi everyone. Welcome to the first Nearpod lesson of the quarter. Today we are working on learning target 6A, which is the same one as we started yesterday, but we're going to really start digging into the important parts of this. So we're working on radical expressions today, which is really just anything that has a radical in it, which is like a square root. Sometimes we see a cube root there. Other times it's like a fourth root, like this, or a fifth root or a sixth root, something like that. Those are all called radicals because they're cool. We're not going to start this part of this until probably sometime next week. Okay, so let's just talk quickly about what the word simplify means, because it's important that you know what I mean when I'm asking you to do a very specific thing. And so simplify means get everything outside of the radical that you can get out, and then you have to leave the rest of the stuff that can't be taken out. Okay, so here's an example. There's a couple of examples here, but here's the big idea. This one is a square root. There's an invisible 2 right there to remind you that it's a square root, but really, the square root just means something squared equals this stuff. So the thing that we need to do is we need to figure out what goes in there, what can we rewrite this as, so that when you square that answer, you get this stuff inside. So if you think about this, 16, the thing that you square to get 16 is 4. So you can rewrite 16 as 4 squared. And you can rewrite x to the 8th. X to the 8th is x times x times x times x times x times x times x times, and then one more. Okay, if you think about this for a second, if you split it evenly, this is an x to the 4th times an x to the 4th. And this right here is just kidding. This is x to the 4th squared, because it's the same thing multiplied together. So you could rewrite this whole thing as x to the 4th squared. Okay, so what do we get here? If we're taking the square root, whoa, that was a horrible square root. If we're taking the square root of all of that stuff, what do we get? Well, we get 4x to the 4th, because that little 2, that little invisible index, this index matches these two exponents. And so we can say, all right, well, then I know my answer is this thing. What is the square root of 12? And this is one of those things where I didn't say you had to simplify this at the beginning of the year or when we were doing quadratics or polynomials, but now it's time to learn how to simplify these. So 12 is 4 times 3. So we can rewrite this as the square root of 4 times the square root of 3. So we can rewrite, like this. Square root of 4 times the square root of 3. Well, I know that the square root of 4 is 2, so we can rewrite this as 2 times the square root of 3. And so then this is our answer, because it's as simple as it can be. Here's the thing. 3 doesn't have a nice square root, so you leave it like this, because this number is irrational, but this number is nice. This number is whole. And so we can rewrite it as 2 square roots of 3. Or you can write it with the multiplication symbol. Either way, it doesn't matter. These are 2 examples of simplifying in this unit. And so these are really good, typical examples of things that you will be doing this unit. What I have here is a little bit weird. Last unit, like when we worked with polynomials, and then the unit before that when we worked with quadratics, we talked about the square roots, plural, of a number. This unit, we are only talking about the singular square root. And so what this means is you don't have to deal with 2 of them. There's really usually just 1. There are sometimes some exceptions, but really, usually it's just 1. Usually when we talked about what are the square roots of 36, we said, well, there was a positive and a negative 1. So that would give us 6 and negative 6. In this unit, when we talk about the square root of 36, we define the square root of 36 as the positive square root of 36. And so the positive square root of 36 is 6. the word that we use to describe that is the word principal. The principal square root of 36 is 6, and so we're going to be only dealing with the principal roots of numbers, this, and variables, this unit. That's what I'm saying here. We're just dealing with the principal roots of each expression, and we don't have to deal with all of the square roots. So it's not important anymore to have that plus or minus for this unit, because we're just working with expressions and kind of simplifying them out and making them work better. And so we don't need this plus or minus symbol anymore, so we can just kind of forget it that ever happened, at least for now. We'll need it again later this year, but for now, we're just kind of working with some tools. We are keeping it real, which means that we're just dealing with the real numbers, and so there are no i's here. Your answers aren't going to have any i's. Usually, if you're solving an equation, it will often only have one answer, but sometimes it will have two, so you just have to be checking your work for extraneous solutions again. Okay, let's do a couple of examples of talking about cube roots of numbers. Remember that if I'm talking about a cube root, what you really can say is we're looking for the principal cube root of 0.008. What this means is what number cubed is equal to 0.008. These two things basically mean the same thing, these two equations. What we're really looking for is what is x. Okay, so yes, you can put this in your calculator, and that's mostly fine. But the thing is, I want to be able to come up with our answer on our own too. And so here's what I notice. I notice that I have some decimal points, which means that I have to have a decimal here. And I know that 2 cubed is 2 times 2 times 2, which is 8. And so my initial instinct is to check what happens if you take 0.8 and you cube it. Nope, just kidding, not 0.8. Excuse me, 0.2 and you cube it. If you check this in your calculator, you will get 0.008. And this is our answer. And so the cube root of 0.008 is 0.2. What is the cube root of negative 1,000? Well, here's what I know. I know that 10 times 10 times 10 is 1,000. And if I make them all negative, then I will get 3 negatives. These two give me positive 100. If I multiply it by another negative 10, I will get negative 1,000. So our answer here is negative 10. 1/27th, well, here's the thing about 1/27th. I know that this is that. Because remember, if you multiply these fractions, you multiply the numerators and then you multiply the denominators. So our cube root of 1/27th is 1/3. If I may drive this home a little bit further, the real root means there is only one. Okay, so what is the real root of negative 8? The cube root of negative 8. Well, I know that negative 2 cubed gives me negative 8. The cube root of negative 8 is negative 2. What is the fourth root of negative 1? Well, here's the problem with this one. If you take any number and you raise it to the fourth power, you're always going to get a positive number. So there is no real root of negative 1. Okay. What about this one? Well, sort of like what we saw with the last one, the square root of 0.4 is 0.2. Because if you take this and you square it, you get 0.04. So 0.2 is the square root of 0.04. Okay, this one is where it gets interesting, and I know that I'm kind of rambling for a moment here, but this one is really, really interesting. If you just think about, well, what is the square root, or what is the value of this expression inside the square root? Well, negative 2 squared is negative 2 times negative 2, and so our answer is the square root of 4. That negative just disappeared. That negative went away because when we evaluated this, we got a positive number. So the square root of 4 is 2. You might be feeling like, okay, wait, this should say negative 2. But remember, we're dealing with the principal square root. And so the principal square root of 4 is 2. The principal square root of negative 2 squared is also positive 2. This is sort of a little bit of a weird kind of formula type thing that explains or formalizes what we just said about that square root of negative 2 squared. Since our index, which is what this number is, and our root, they match, but they're also even. That means that our square root, our answer to this square root is the absolute value of negative 2. The absolute value of negative 2 is 2. So that's sort of the formula type reason for our answer from the last one. Okay, all of that running around that we've been doing is really for a reason here. Because now what we have is we have the tools to simplify these types of expressions. What we're looking for is we're looking for these things that look like n times a to the n. So we're trying to match this exponent with this index right here. And so we're trying to get these to match. So this is where those exponent rules from yesterday come in, because a to the 6th is a squared cubed. And b to the 9th is b cubed cubed. And so if we rewrite this original expression, we can rewrite this as the cube root of, not a to the 6th, but a squared cubed, and then b cubed cubed. And now we have this, because now our exponents match the index of the radical, and so we can rewrite this as a squared b cubed. Okay, so that's that. Our answer is a cubed b cubed, because this is a simplified version. There's no more radical. There's as much stuff out of the radical as we want, so as we can get. So I suppose I should have written here that the instructions here are simplify. That's this process. Okay, this is another simplify problem. Okay. X to the 8th is x squared to the 4th. Y to the 12th is y cubed to the 4th. Notice now I have matched my index of my radical to the exponents on the outsides there. Okay, so what do I get out? Well, I get x squared y cubed. Here's the problem though. If you take a negative number and you put it in here, like negative 1, negative 1 to the 12th is 1. You can check that in your calculator, but you can also see this is an even exponent, so you're going to be multiplying a negative 1 times a negative 1 an even number of times. And so that's going to give you a positive. But if you take that same negative 1 and put it into the same spot right here, that's going to give you a negative 1. So we have a problem here, and this is why that absolute value thing is important, because now we have an answer that doesn't actually stay equal anymore. So our answer has to be x squared times the absolute value of y cubed. That keeps it so that this part is always positive. Because this part right here has to be always positive. Okay, so we need this absolute value here, or else we don't have an equivalent expression anymore. Okay, so I have a couple more examples here, and I'm not sure that I'm going to do all of them. I'm just going to do this one, I think. But here's the deal. Here's what I want to start with. I want to start with what the values I could put in are. Like, what could I possibly put in here? And here's the thing. I can put anything in for x, because regardless, this must be positive. Whatever you put in, even if you put in a -1 here, you will get a positive number out because you're raising it to an even power. This part right here, this could be negative. So if you put in a -1 here and you cube it, or you raise it to the 13th power, you'll get a negative number out. But here's the problem. Remember when we started at the beginning of this lesson and we said the fourth root of -1 doesn't exist? It's not real. What this means is we have to restrict the domain. We have to say, okay, you know what? Y has to be greater than 0 or equal to, could be equal to. You can't put in a negative number into this expression because otherwise you'll get an error out. So that's going to be important after we get to our answer here. So this is important because you can't put in a negative number anyway into this for y. The x domain is anything. You can put anything in for x. So you can put in all real numbers for x. Okay, let's see what we get out when we start simplifying. So remember that x to the 12th is x to the 3rd to the 4th. I'm choosing it in that order because I want to match this to the index of the original radical, okay? Y to the 13th, this is another exponent property. You can write y to the 12th times y to the 1. We can rewrite this y to the 12th as y to the 3rd to the 4th. So now we have x to the 3rd to the 4th, y to the 3rd to the 4th, and then we have a y hanging out at the end. We're still taking the 4th root of all of this stuff, so I should have had that there also. Okay, but now we have the index matching the exponents here and here. So we can take those things out. Like that. We still have the 4th root of y in here because that's what is left here, right here. Okay, so what parts of this need absolute value? Well, we know that we can put anything in for x, but our answer here must be positive. So the x part needs an absolute value on it, because otherwise you could get a negative number out here, right here. But we want it to be positive. Remember that we can only put in positive numbers for y, or non-negative numbers for y. So regardless, if this part is undefined, if you put in a negative number, the whole thing can't be defined. So you don't have to worry about putting an absolute value around the y to the 3rd here. Our final answer is x to the 3rd with an absolute value around it, y to the 3rd, you don't need absolute value there, and then times the 4th root of y. We do have to write y is greater than or equal to 0 here. Otherwise, we don't have a correct answer because we just have to say, those are the values you can put in for y. We don't have to write anything about x because x can be anything. So that's that. I've been saying this vocabulary so far today a fair amount, but I just wanted to really formalize it. This number right here is called the index. The symbol itself, that is the square root symbol or the fourth root symbol or the third root symbol or whatever, is called a radical. So if I say a radical expression, that's something that has a root symbol in it. And then the stuff inside the radical is called the radicand, but I always forget that word, so I often just say the stuff inside. It is called the radicand, though. Just a quick reminder here, these are sort of the things to check for, things to make sure of. This is the sort of formula for if you need the absolute value or not. It's a little bit tricky because sometimes the domain, like we saw in the last one, changes the answer for the absolute value or whatever. Okay, is it even or odd? If it's even, if you have an even parity, if your root is an even number, then you need the absolute value in general. But the thing that you need to do is you should check by putting in some values for negative numbers, each variable at a time. Okay, let's do a little more simplifying. Let's just do one more. Okay, so we'll deal with this absolute value question in a minute. Let's talk about what values we can put in, and what values we can get out. So if you put in a negative number for x, this to the fourth will make it a positive number. So this x to the fourth is always going to be positive. We need to make sure that our x to the fourth is going to be a positive number when we take it out of the radical. This y to the 18th is also going to be always positive. So we'll see if we need to do something with that also. Okay, so let's see what happens here. 162 is, and the only reason I know this is because I just looked at it in the calculator. 162 is 81 times 2. I'm choosing 81 because 81 is 3 to the fourth. So then we still have this 2 in here. I already have, so this now matches this. This already matches, so I can just copy it, x to the fourth. And then y to the 18th is, I could take y to the 18th and go, okay, well, this is y to the 16th times y squared. Or y to the 16th is y to the fourth to the fourth. Okay, and so what do we get here? Well, we're going to have y to the fourth to the fourth. Okay, we're still taking the fourth root of all of this stuff. And now we have some stuff that matches the index of the radical. Okay, so what do we get on the outside of the radical? We get our 3. We get our 3. We get our x. And we get our y to the fourth. Oh, I lost my y squared. So there needs to be a y squared in here also. Okay, so then inside the radical, what do I have left? Well, I have the fourth root of, I still have my 2, and I still have my y squared. Okay, what needs absolute value here? Well, remember at the very beginning I said x to the fourth is always going to be positive, but this x right here is not always positive, because if you put in a negative number right there, you get a negative number out. And so this needs absolute value to undo that. Y to the fourth is always positive, y squared is always positive, everything else is always positive going on. So I don't have to deal with that stuff. This is our final answer. If you don't believe me, you can go back and think about what happens if you put in -2 for x up here and 3 for y here. Check that to make sure that matches here. What about if you take -1 and put that in for x up here, and -2 and put that in for y up here. What happens then? Does that match here? That's going to tell you something about what x and y have to be. And so that's why I know that I'm going to have some absolute values. So you can experiment with that a little bit yourself. Okay, so summarizing, what have we done today? We started simplifying some radical expressions just by looking for matching exponents and then taking those things out of the radical and writing them on the outside. We also checked to see if there were absolute values that needed to be there on the final answer. That's the tricky part here, and I'm going to be a little bit flexible about how accurate you are about that, but it's kind of that kind of next step of algebra is like, how are you understanding what you put in and what you get out of an expression, and how do you make sure that they're the same? For the rest of today, you have to complete a practice assignment. It's like 6 problems, I think. There's an answer key on Google Classroom for you to check your work against. And then there's a mastery check that you have to click on a Google form and finish that. So that's that for today. Thanks, everybody. See you Thursday, next lesson.